this computer. Okay, today is the last session. I think I'm the last lecturer who are giving a talk on this training. People said that save best for the last. Hopefully, I will share my experience on doing a project with Guilin University of Electronic Technology, Renko PTE Limited, Private Limited China, as well as China government or China government agencies. This is more to the sharing experience, a little bit on the information or knowledge on the signal processing of GNSS, and the rest is more to the my experience on doing project on landslides. I believe all of you have listened to the previous speaker. Maybe some of the information is similar because we are talking about the same thing, GNSS, and also application to landslide. So I'm seek your apologize if some of the information maybe is duplicate. So let me share my slide. I've prepared a slide here. It's 100 something slides, but I will skip those slides who are not really important. I will try to complete this session within 1 hour or so. Yeah. Okay. Actually, I amend a little bit on the topics. I would like to talk about signal processing as well as the project of the landslides, land deformation system where we deploy on the Malaysian highway. But I also would like to talk on my research on the signal of GNSS. So part of the topics is about signal processing of GNSS. My name is Kamarul Hawari. A little bit about me from University of Malaysia Pahang. I've been working with UMP from since 2002. Currently, my research is on applying deep learning in agriculture. We have a project with industry, a few projects with industries like Sandabi. 2 weeks ago, I visited one of the bigger plantation pineapple in Johor. I'm also have a project on GNSS navigation and positioning, particularly on landslide monitoring, and also applying deep learning in biomedical application. So that is the research, because as a lecturer, you have to do research. But most of my research is with industry. We are applying the algorithm like a signal processing algorithm, image processing, navigation and positioning to solve the industrial problem. So this is the outline of the talk today. Introduction, UMP, GUAT, GNSS lab. We have a lab that we collaborate with Guilin University of Electronic Technology. I will talk a bit, I will brief a bit on this collaboration, the lab, and a general overview of landslide monitoring system, landslide project in Malaysia. This is the project of installing Beidou GNSS to monitor slope in Malaysian highway, and a bit sharing about research in signal processing of GNSS signal. So that is the outline for today's class. So this is the starting point of our collaboration. The collaboration with Guilin University of Electronic Technology is about Beidou satellite, but we are more to the application applied. It's not to the develop the system of the satellite system, but more to the application. So let's watch this video. Um, this one thing that stopped was this. Yeah, this is yeah.
Hello,
Oh,
Captain.
you cannot see the.
Uh, uh, I couldn't hear the voice. Is the video?
Yeah, yeah. Okay, never mind. Let me. I'm sorry. Let's skip the video.
Okay.
Okay. Just the video just to share with you that the final launch of last satellites to the orbit somewhere in July this year. So it means that um, the satellite is ready to be used. But I just keep the slide. So um, this is the collaboration. We have this GNSS Lab UMP GET Global Navigation Satellite System Laboratory, where we collaborate with Guilin University in China Space Agency, if not mistaken, and University of Malaysia Pahang. Uh, it was started in 2016. It is already 4 years. Collaboration between UMP and GNSS Key Laboratory was started since 2016. The MOU signing ceremony in September 2016 with President of GUAT. So this is the starting point of our collaboration. So the area of collaboration is not only on the research, but it is also on the academic collaboration. But we still yet not doing this part of the academic collaboration. Within these 4 years of cooperation, we are more to the research. But I think I'm very positive that one day uh, our vice chancellor will discuss about on the academic collaboration. But this cooperation is more to the research, joint collaboration, SPEAK program, and any other areas of cooperation to be mutually agreed. So this is the signing by previous vice chancellor. Now we have a new vice chancellor, witnessed by me that time in 2016. So this is the lab. We are renovate this lab uh, to be ready for uh, to allocate the equipments. Right, we have equipment given by the Guilin. So we do the renovation. So this is the lab. You are welcome to visit this lab. All right. So the cooperation with the Guilin University, particularly on the Beidou, is the co-establishment of joint lab. We done this part. Establishment of GNSS ionospheric observation station. We also done this part. We have the observation station at the lab. Uh, we have a monitor, one equipment where we can collect the data to monitor the signal of Beidou. So this is the detail of the collaboration, Chinese GNS quality monitoring and assessment technology. So this is all the activities that we are planning to do with the China: product development, promotion indoor and outdoor, high precision signal simulation, and also education training. So now we are doing this part, education training. This is the phase one. We have the second phase maybe next year. We are going to have the face-to-face training. Hopefully uh, the COVID uh, clear, then they can come here so we can have the face-to-face training. All right, this is the equipment that I mentioned just now. We have this equipment uh, for the quality monitoring and assessment. This is, we call it, uh, this equipment is to collect the data for a signal to study the effect of ionospheric TEC scintillation monitor. So we did the research on this part, and a few paper has been published, particularly for the Beidou signal, the effect of ionospheric. So the other collaboration is ongoing: product development and promotion, conduct pseudo code and carrier phase measurement, carry out multi-frequency, develop a Chinese GNS navigation timing terminal with high precision. Okay. So this is all the details activities that we are planning to do with our partner in China. This is the joint lab. We done this part. Okay, education training. Yeah, so we have a series of training before, but this time this training is open to participants from not only from UMP, but before this we did a few series of training just specific for the students and also the lecturer from UMP. But this time we open the training uh, to others as well. So a lot of activities actually has been planned with Guilin University, Beidou Agencies of China. So if you are interested to join the research activities, you're welcome to join the GNSS lab at University of Malaysia Pahang, those who are staying in Malaysia. So we together can do the research on the GNSS. This is the latest one, 2019. We signed the MOA because there is a financial obligation. That's why we need to sign agreement. We received some fund from Guilin to conduct research on application of the Beidou, together with a company from China. So this is the latest one.
Hello, Professor.
Yeah, yeah.
Sorry to interrupt you. Could you enlarge the slide?
You can
Because enlarge the slide. Because a little unclear. When there is a lot of words.
Okay, now it's okay.
It's okay.
Okay. Um, so this is the latest one. We signed MOA to conduct research uh, and install the land deformation monitoring system. So we did the collaboration with Lembaga Lebuh Raya Malaysia. This is the Malaysian highway authorities. ANEH MTD. ANEH MTD is a a contractor to maintain the Malaysian highway, and also Aloy Berhad. So new MOA has been signed between UNP, Guilin University of Electronic Technology, and Guangxi Rongqi Technology Co Limited. So a system will be installed at kilometer 94 eastbound, east and west actually, but because of the limitation of budget, so we decided to just install at the eastbound Lebuh Raya Pantai Timur highway to monitor the highway slope. So if, if it's happened to you to use the LPT highway, the location of the system is just a few kilometers uh, from Lanchang, uh, entrance of the Karak. Yeah, Karak. You just see the signboard. There is a kilometer 94. There is a slope, very big slope, and at the back there's a quarry. So we have been advised by the LLM, the Lembaga Lebuh Raya Malaysia, to install at that location because that slope consider the level 5 or level 6 of critical slope, something like that. So the monitoring system will be deployed based on the data collection at kilometer 94 LPT. So this is a letter from the Lembaga Lebuh Raya Malaysia. So this is the new MOA signing last year in 2019. I've been every year since 2016 until 2019 has been invited by the Guangxi province to attend the forum, um, satellite forum at the China ASEAN exposition. But this year they are not organized because of the COVID Car Expo. So we did sign the MOA last year. So this is the site survey. It's happened last year, July 2019. A representative from Guangxi, from Renko Guangxi Private Limited, from the highway, Malaysian Highway. And this is the students from Guilin University of Electronic Technology. So we identify the location. There are 7 locations to be installed, the system at the highway slope. There are 6, 1 base station and 6, monitoring station. Yeah, 1 base station and 6 monitoring station. We are decided to monitor both sides because the both sides, east and westbound, there is a slope. So we decided to put 7 stations there, collect the data and do the research and monitor the slope. So this is the content. I just skip this one. Actually, at the beginning when we proposed to the Lembaga Lebuh Raya Malaysia, they are asking about the security. I mean, securities issue. But I'm explaining to them that this is the system like GDS is same. It is just use a Beidou, but because of maybe they are not familiar with the satellite, then they're asking for to get the approval from the government. Then I contacted SKMM. SKMM is a Malaysian agencies who are looking at the frequency, something like that. So we receive a very positive feedback from them. So there is no issues to do research on the Beidou satellite. So that's all about a little bit about the collaboration and also about the project. So next we move to the landslide monitoring system. In general, we have we have a few methods or techniques of landslide monitoring system, not only using Beidou or GNSS, but the conventional method. There are a lot of the conventional method that can be used for landslide monitoring. So general overview of landslide monitoring system. So this is all the techniques that can be used for landslide monitoring. Those who are in remote sensing, uh, you are familiar with this, but those who are in electrical, electronics or software, computer, uh, all the equipments or instrument used by the remote sensing is actually related to electrical and electronics. And the data that gathered from the instruments is processed by those who are related to the software. So, so it is relevant. So this is all monitoring system of landslide, remote sensing or satellite techniques, photogrammetric techniques, geodetic or observational techniques, geotechnical or instrumentation or physical techniques. So the project with GNSS is the third one, geodetic or observational technique. We have also a method or techniques where nothing to do with satellite or remote sensing, which is geotechnical or instrumentation. We deploy the instrument on the slope, for example, or then we can monitor the condition of the slope. A little bit about remote sensing techniques. There are a few techniques under the remote sensing. SAR, synthetic aperture radar, interferometric synthetic aperture radar techniques, ground-based or satellite-based. So this is the information about the SAR and INSA. It is basically synthetic aperture radar imagery is produced by reflecting radar signals of a target area and measuring the two-way travel time back to the satellite. The SAR used the spacecraft motion to simulate an extremely large antenna. So INSA is advance of the SAR. Interferometric synthetic aperture radar is an effective way to measure changes in land surface altitude. INSA makes high density measurement over large areas by using radar signal also from Earth orbiting satellites to measure changes in land surface altitude at high degrees of measurement resolution and spatial detail. So this is the illustration of SAR and also INSA. So the data, the reflection of data is transmitting from the satellite to the ground surface, and the reflection we collect back to the satellite and all the information gathered, and then we can see we can have a lot of information about the ground surface. So it is same goes to the INSA satellite. So advantages of INSA is ideally suited to measure the natural hazards. It is often less expensive than obtaining sparse point measurement from labor-intensive spirit leveling and global positioning system or GNSS surveys, and can provide millions of data points in a region about 10,000 square kilometers. So the area is very big, but the disadvantages: skill crew required for operation, displacement along line of sight, cannot be any obstacle, fails in detecting large and rapid displacement or signal decorrelation. So for the remote sensing techniques that used for landslide monitoring, so this is basically the overview of the techniques applied to the landslide recognition. The method first is landslide recognition, interpretation and geomorphic feature extraction. And then we can use RS remote sensing tools, photogrammetry for high resolution and very high resolution satellite images for visual, and we can also do the automated. But because of the nowadays because of the advanced technology on automated system, we can apply uh, a few algorithms to make it automated. So when we have a data from the remote sensing for landslide recognition, the detection can be done automatically. Because sometimes when we rely to visual by human, it may cause some other problem like uh, 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 inefficient or something like that. So in research now, uh, some researchers are doing this part. We get all the data and we're trying to do the automatic system of landslide recognition. Okay, so this is the information about landslide. Landslide are major natural hazards. Yeah, it can cause a lot of damage to the country, cost for the society, loss of productivity, reduction of real estate values, loss of tax. So it is important to have early prediction and warning, and then essential for mitigating such impact. So among these, one of the most important contribution has been the impressive development of remote sensing techniques since early 70s. So it is very important to have a system for landslide monitoring. I have an opportunity to present this GNSS to Indonesia because in Indonesia, landslide or volcano is like uh, always happen there, right? They are very interested on the method and technique, but the problem is on budget lah. Hopefully we can go to the Indonesia one time because we have a participant from Indonesia, if not mistaken, so they can help to bring this system to Indonesia. Remote sensing for landslide, there are three main groups. First, recognition, classification, and post-event analysis. Monitoring the activity of existing landslide, and landslide susceptibility and hazard assessment. So there are three groups of the landslide recognition. The term landslide recognition includes all those activities aimed to recognizing past landslide events that occurred in a specific region. So there are four main kinds of remote sensing data types: optical, thermal, microwave, and laser scanning data. So this is all the data that acquire from remote sensing for where we can use for landslide recognition and detection. So in such categories of application, optical and thermal remote sensing are usually accomplished from airborne and spaceborne platform, and rarely from ground-based platform. Microwave sensors are installed on airborne, spaceborne, and ground-based platform. Laser scanning is implemented in airborne and ground-based platform. Some of the method or some of the instrument is very useful to be used in other application as well. For example, laser scanning, LIDAR. LIDAR. Now is the hot topics is LIDAR instrument. I mean, it's not only for the geoinformatics application, but also in other applications. So this is the illustration of the optical passive sensors for landslide recognition by optical. So it is still transmitting from the satellite, get the reflect signal and information of ground surface. Okay. There is another instrument on the remote sensing, thermal infrared. Um, it is first used by remote sensing, but now thermal infrared also being used by other application as well. I mean, it's not on the remote sensing, but I have a thermal camera. I bought in 2009, thermal camera, very expensive. The thermal camera. Yeah, the FLIR thermal camera. The cost is RM 317 ringgit. uh, I bought 10 years ago, and a lot of application has been done by that instrument, thermal camera. And now the thermal camera is widely used in you know in strategic location for thermal temperature, because of the COVID. I still remember one of my research project is to automatically detect uh, the temperature, human temperature for H1N1. Last 5 years ago, I have one PhD students who are graduated and working with MIMOS now. So she did that research to automatically detect the temperature at the airport. We collaborate with the um, one of the clinic in Kuala Lumpur International Airport, because if you notice that when you arrive at the international arrival, there is a station, there is a thermal camera. So we work with them actually to develop a software to automatically detect um, the temperature, human temperature. So the thermal infrared is used for remote sensing. It's also very useful information or data that can be acquired for, see, changes in temperature in terrain, vegetation, and influenced by the weather, soil, climate, relief, slope, aspect, and land use practice. So TIR satellite mission seems to be more attractive in the research domain, and because we can get a lot of information of a signal from the reflection of thermal infrared. Um, because of the all the object radiate a different radiation, then we can have a lot of information from the thermal infrared. For example, forest, water, grass, soil, paved road, built up area, so on and so forth. So all this information is very useful, and we can analyze it. Then we can do landslide, for the landslide um, detection or recognition. So that is the thermal infrared. So this is the information looking at the thermal infrared. So you can compare the aerial RGB image and the couple thermal vegetation matrix. So cooler, greener than average, hotter, less green, cooler, less green. So this is all the information that we can have, uh, so that we can analyze it, and and it gives some indication whether what's going what's going on and that in and at a certain area. But sometimes when you look at this thermal data, you cannot get the information of from as what you see from the RGB. Yeah, from the RGB, you can identify where is the location easily, right? I mean, you can see the building and so on. And but here, a lot of information, I mean, the visual information have been missing. This is only the information of thermal. I have one of my student is doing, they call it fusion. You can get the thermal information and visual information from the same image. If like this, you need to see the thermal, and then you go back to the RGB. A little bit maybe confusing. So I've one my PhD student is doing fusion both of this information on one image or one frame. Next is a microwave sensors. In landslide investigation, the most widely used microwave or radar sensor is SAR, an active system capable of recording the electromagnetic echo back scattered from the Earth's surface and arranging it in a 2D complex value. So this is the another method or technique for to acquire data from ground surface by using microwave. So this microwave is a uh, one range in the wavelength. But now we have a, they call it a multispectral sensor. In the multispectral sensor, there is a few range from a certain nanometer to the up to the certain nanometer. So so that sensor can emit the the wave and the reflection of object can get five up to five band, including infrared, microwave, visible, so on and so forth. So a lot of information we can get from this multispectral sensor. It can be used for other application, not only for the recognition of the landslide. Maybe it can be used also for other application because we have the signal reflection we can study, and we can know the details of what is the reflection all about. So it's very interesting. That's why in Malaysia, uh, I think last few weeks, the Selangor State award 2 million ringgit for one company to fly a drone to monitor a river in Selangor because of the pollution. So that drone is actually equipped with multi-spectral sensor, so they can do a mapping of the river. But that one is only for mapping lah. But you cannot do it's just for monitoring. But you cannot do for enforcement, for example, like just monitoring. Monitoring means that when it is happened, then you can know. But sometimes it's already late. So we have to design a sensor that can protect any contamination or pollution to the river. So that's about the sensor. But now we are talking about the landslide sensor. Now, this is a very interesting also. LIDAR helps in capturing the minutes details of these events and offers an parallel and incisive view. Landslide data from LIDAR is obtained either by analyzing the terrain surface or from change detection between surface data acquired at different times. That's why I say LIDAR is used for remote sensing, but it's also used for other application, especially for autonomous vehicle, because it is gather 360 information, surrounding information of car, and map it, and and the car can get information every second for the autonomous car. It's very interesting, this sensor, but it is very expensive now. So this is the data that acquired from LIDAR. So we can analyze this data and recognize whether there is a landslide or not. Right. So the analysis of the data can be by visualized, and it also can be done by automatic. That's come the data processing. So this is the software using LIDAR. Landslide in northern Kentucky. See, very interesting data that acquire from LIDAR. So this is the remote sensing, the YouTube. I think I just skip this part. So other techniques of landslide monitoring, photogrammetric techniques can be an effective tool for monitoring actively moving landslide. So this is the photogrammetric is the science and technology of obtaining reliable information about physical objects and the environment through the process of recording, measuring, and interpreting photographic images and pattern of electromagnetic radiant imagery and other phenomena. So advantages of the photogrammetric techniques is and speed at which the data can be collected, 3D mapping, and least cost broad view of the map, easier to resurvey and re-evaluate. Disadvantages: photogrammetric survey is not possible in the absence of light. It cannot be used for accurate measurement when there are visibility constraints. So this is another technique is geodetic. This is the one that we are doing now. I mean the GNSS now. It is called geodetic techniques. It is ground-based geodetic technique, make use of many instruments and methods of a measurement. They are usually employed according to an episodic monitoring program. A sensor can permanently put on an observation point and perform measurement to targets on control points according to a computer control program. Satellite-based geodetic techniques make use of satellite positioning system such as GPS or Beidou. So there are a number of methodologies applied that can guarantee high accuracy, continuous and reliable results. So I think this is the latest techniques for the landslide monitoring. So the advantages: the signal is available worldwide, therefore users will not be deprived of it anywhere. GPS can be used anywhere in the world. It is powered by world satellite, so it can be accessed anywhere. The system gets calibrated by its own, and hence it is easy to be used by anyone. So that is the advantages of the GNSS. The GPS chip is hungry for power, but I think this is not really a big problem because we can have a solar as well to charge the power. GPS does not penetrate solid wall. Okay, so we need to have a uh, open. There is no make sure there is no obstacle. The accuracy of GPS depend on sufficient signal. Another problem is that the position can occasionally be significantly in error, especially when the number of satellites. So this is the disadvantages of the GPS or GNSS techniques, but we still can improve by doing research on this problem. So next technique is a ground-based conventional surveying technique. This is by land surveyor measure horizontal position. So the project that we did with the Lembaga Lebuh Malaysia, Malaysian Highway Authority, they don't have any system. I mean, any like a geodetic or system that uh, monitoring for the monitoring slope. They are using this one, ground-based conventional surveying. So that's why when we propose the GNSS system to monitor the land deformation, they are very happy, and they are welcome us to install the system at the highway. In fact, it's we install the system for free for them. But in future, maybe if it's okay, maybe they can ask to install at different location. So this is a ground-based conventional surveying. Land surveyors measure horizontal position in geographic or plane coordinate system relative to previously surveyed position called control points, most of which are indicated physically in the world with a metal benchmark that fixes the location, and as shown here may also indicate elevation above mean sea level. So this is the method of ground-based conventional surveying technique. Advantage: a visual inspection, proven methods of verifying accuracy, the most accurate way to measure elevation of geographic features. But the disadvantages: line of sight obstacles such as building, vegetation, labor intensity, and cost, slower acquisition of data because it is relied to the human being. Geotechnical techniques is a sensor instrument. Geotechnical techniques make use of sensors permanently working on or in the structure of region under consideration. So they can operate 24 hours. They can also use as telemetric system for real-time transmission of measurement data to a control center. So this is the method where we deploy in instruments at the target location. So maybe a few sensor need to be installed. So we make it network connected to each sensors, so that we can monitor uh, if there is any changes of surface or land surface of that area. So advantages, this can be useful for gaining an understanding of subsurface topology if a goal is to create a multidimensional map of the subsurface surface geological condition. Disadvantages, this often mean removing many samples from the site, getting them safely in an organized way to a lab facility somewhere, hopefully nearby, and waiting for the lab result to come back. If there are apparent conflict in data or a particular part of the site needs more evaluation, the entire process need to be started up from scratch again. So that is the disadvantage. So this table make a comparison of all method and technique. So the comparison is on the accuracy. So we can see, I think the GNSS method of the RTK is given more precise compared to the other. So next is a landslide monitoring in Malaysia. Um, I'm not doing. I didn't study the existing method of the landslide monitoring, but this landslide monitoring is about the project of GNSS, where we are going to install at the Malaysian highway, East Coast highway. So this is the photo of landslide. It's very bad if landslide is happen. See, a lot of damage. Okay, the GNSS is not only for the landslide, but it is about deformation, land deformation or structural high risk structure. It can also be installed to monitor the structure. So this is the example of 11 of the biggest structural failures in history. 1940, the Tacoma Narrow Bridge twisted and bucked in the wind before collapse. This is the Hyatt Regency in Kansas City collapsed in 1981, killing 114 people. The dam failed to handle once in 2,000 years flood in China. Okay, there are a lot of major structure failures and collapse. But this is the one in 2013 in Penang Second Bridge, Penang Island, Malaysia, 1 killed and 3 injured. Okay, so you can see the other uh, major structure collapse in the world. So specifically in Malaysia, this is the map that for the geological hazard in Malaysia. So this is the area where the high risk, medium and low, and the white point here is the historical landslide location in Malaysia. So it is very important to have a system so that we can monitor or we can predict any landslide to be happen. So this is in 2003 rockfall at New Klang Valley Expressway. So you can see the photo here. In Penang, Malaysia, Tanjung Bungah landslide was a man-made tragedy entirely preventable. This is a report in 2019. Worksite incident of landslide at Tanjung Bungah in Penang Island. So this is the list of landslide in Malaysia, August 1996, 2006, 2007. So a lot of landslides happen in Malaysia. So it is crucial to have one monitoring system so that we can prevent the we can have early precaution or early monitoring, early warning. Okay, so this is the photo of the landslide in Malaysia. This is the latest one in Cameron Highland. There is one guy who fly the drone and post this photo to the social media. The Cameron Highland is the tourist spot. Uh, uh, so this is the Simpang Pulai highway. Then you can see the slope here. It is very dangerous. We are proposing to the Pahang state, but yet we are find the best. I mean, trying to make appointment to the ESCO to present the system so that we can monitor here. We can deploy the GNSS monitoring so that we can monitor this slope. It's very critical. So it is not only for landslide, we can also use for the formation of tower and building. Okay, landslide is very close related to the deforestation. So you can see the maps of deforestation rate in Malaysia states. So this is the Highland Towers collapse. 48 people dead. Highland Towers incident was estimated cost 184.9 million in damages. So that's all about landslide or as well as the structure collapse in Malaysia. So it is very important to have a monitoring system. I think this is the right time for Museum Malaysia Pahang to bring this system to the Malaysian highway as a showcase, and also we do some research based on the data, because sometimes it's not easy to make a decision. We need to analyze the signal to make a decision, because when it is wrong decision, it can cause other things, right? So now we are talking about the GNSS based deformation monitoring system. So this deformation monitoring is not only for the landslide, land deformation, it's also for dams, bridge, high-risk building, steep slope, concrete slope, and etc. Maybe some of the slide has been shared by the other speaker, so I just make it very fast. So GNSS provide global satellite positioning for deformation monitoring. So this is all the GNSS, but now we are talking about the BDS, Beidou Satellite Navigation System. So this is the overview of GNSS for landslide monitoring. Okay, land structural deformation system, precise direction monitoring, on-time deformation for on-time deformation monitoring for landslide, building, dam, bridge, tower. So this is all real-time monitoring. So we need to have a receiver, satellite receiver, so that we can have all the signal and data. So this is all the hardware that for the monitoring. The device consists of 4 to 10 GNSS monitoring system. Monitoring board which can send real-time satellite observation data to the observer by optional wireless module. So this is all the hardware used in GNSS monitoring system. So this is the very important part of the decision on the software part or on the signal part. So this is the signal looks like the. So this is very important decision. Initial deformation stage, early accelerated deformation, near landslide stage, midterm accelerated deformation. So this is come to the data processing or signal processing of GNSS signal to come to the decision of the landslide. So this is the data looks like. Okay, this is the raw data. Sometimes it is very difficult to analyze by visual. Then we need to have some algorithm. This is real-time kinematic positioning of the signal positioning. Then we can apply a Kalman filter so that we can get a good signal, very clean. So remove all the noises. Okay. So next is a data processing. So this is the part that I'm doing now on my research. We acquire the data, analyze the data, process the data, apply some filtering method to remove noise, and finally make a decision. So this is the same thing, same like previous slide, hardware development, hardware part, high precision board. We use the ARM FPGA to receive the signal of satellite for positioning. So this is the specification of the board, FPGA. The hardware, so uh, the same data like previous slide, then apply the Kalman filter, then we can get a good output of the signal. So this is the all about the hardware. This is the detail of the hardware. Okay, this is the software algorithm, early warning algorithm by using Kalman filtering. Then we can test simulated test equipment and test result. So this is the actual result, the same slide. So apply a Kalman filtering, that we can get the wanted signal. This is a raw signal. Remove the noise, then we can get the signal. So signal processing of GNSS. There are a few methods that we can use for signal processing. But in the GNSS monitoring system, this is the futures. They call it RTK, real-time kinematic, has been the most widely used GNSS technology in SHM, structural health monitoring, for more than 2 decades, and is also the most mature GNSS technology. So this is the technology in GNSS that being used for land deformation or SHM. So typical application scenario for RTK in structural health monitoring include bridge and super high-rise building monitoring. So next figure shows a typical deployment scenario of RTK in bridge dynamic monitoring. So this is the example of structural monitoring in Singapore. They have a base station like this, reference station, rover station. They call it reference station or rover station. A base station equipped with a geodetic GPS dual frequency receiver installed at a stable place nearby. In our project, we call it base station. Same. 2 dual frequency receiver were installed on the 66th floor of the Republic Plaza building as rover station. So a control PC for running the monitoring software. So base station and monitoring station will communicate to each other, and PC with a monitoring software will monitor if any changes of position and also angle of these two locations. Okay, so this is basically the basic concept of RTK for satellite cover on the surface on the space, and monitor the position, transmit the signal positioning of A and B. But this is the detail, reference station and rover station. But in our project, we call it the reference station, we call it base station. The rover station, we call it monitoring station. So we can use a Kalman filtering just now. This is one of the algorithm that can be used uh, for data fusion also, and also can be used for uh, noise filtering in order to get the signal, positioning signal. So this is information about the Kalman filter. There is a method to call it a multi-rate Kalman filter, can be used for data fusion of displacement and acceleration response measurement in dynamic monitoring. The other filter, the other method can be used for signal GNSS signal processing is a adaptive finite duration impulse response filter, AF. So this is one of the algorithm that can be used for signal processing. So this is the AF adaptive filtering configuration. So I don't want to go to details on this part unless we do research and we have the signal and write a coding, remove the noise and get the final signal. So this is how the signals looks like when we apply adaptive filtering. The other the other algorithm or techniques for the GNSS signal that also can be used is wavelet. This is a very famous one. Can be used in any other application as well, for mainly for signal processing. We have a raw data with wavelet decomposition, make a thresholding, wavelet wavelet reconstruction, and we get filtered data. It, this is the typical block diagram, but this is not as easy as this. A lot of other, I mean, step need to be done rather than just this flow. It's not as simple as it, but the typical block diagram of the wavelet analysis is like this. But if you do research by using wavelet, a lot of things need to be done to get the wavelet coefficient, wavelet family, a lot of things. And finally, you get the filtered data. So this is the example of the wavelet denoising of the signal, GNSS signal, a lot of noises, a lot of noise. Then use a wavelet to get the wanted signal and remove the unwanted signal. All right, so we come to the end. This is a new one because I'm now exploring a deep learning algorithm. Normally, deep learning is actually from the family of the artificial intelligence. Deep learning is part of the artificial intelligence, and it is in the family of machine learning. But uh, deep learning is subset of the machine learning. We have the other uh, artificial intelligence method like ENN, neural network, support vector machine, so on and so forth. But this deep learning is very powerful. Uh, it is widely used now. I mean, uh, it is used for the real implementation because some of the algorithms sometimes is not ready to be used by in real, I mean the real world, real time, something like that. It is just maybe ready to be used for research to publish paper. But this one, deep learning, if you are familiar with this one, it's ready. It is used a lot in autonomous vehicle. It's very very powerful, and you don't have to know much about the fundamental because the algorithm is actually ready on the shelf. It's been created by the Google people in Google, in Alexa. A lot of people improving the algorithm. So we just take the algorithm and apply to a very specific application. So this one can be also applied to the signal processing of GNSS. All right, because it has a lot of advantages. I make so this is the overall uh, illustration. Acquire a signal, label a signal, and then we can make a classification of the signal. But this is a very, I mean, very interesting part to be shared with you all. Uh, those who are doing a signal processing, uh, the step of signal processing, you apply algorithm to get the signal, to remove noise, apply algorithm or method to get a feature extraction, get the features, and do the classification. But when we apply deep learning can be applied direct to the raw data. So raw data from the GNSS, for example, it is very bad data. Even visualize, you cannot differentiate it. I mean, if you look at the data, the signal, it is very hard to interpret. But when we can just take all the raw data, give to the deep learning, and let deep learning learn. That's why they call it deep learning. Learning, they can learn. Some code said that um, um, deep learning can make decision even better than human. That's the artificial intelligence. Those who are doing artificial intelligence know this statement. So we can just take raw data, apply deep learning. But we need the data size. The data must be, the size must be very high. A lot. We need a lot of data because it's learned. Then you need to give a lot of data so that the algorithm can learn by themselves. But if you have low data, then you can just apply like this machine learning with many features. If you have features, you apply other method, remove noise, get features, then you can apply machine learning with many features. So data set is low, model complexity is low, model complexity of the machine learning of deep learning is low. But if you don't want to process the data, you just take the raw data, apply deep learning, but perhaps you need to have a lot of data, and the model complexity is very high. But don't worry about the model complexity. It is ready actually. This is my experience. That's why my research now is go to the industry and provide solution to the industry because of this algorithm. It is very powerful and very good. So this is the flow chart of the deep learning. If you are interested to know details, we can have another other session of the deep learning. So my next project is to apply the deep learning to the GNSS. So we don't have to use a Kalman filter to remove noise. We just take all the raw data, put it in train using long short-term memory or any other network. Then we can do the prediction. We can have the detection or classification. So all the information about the deep learning, you can get it from this, but a lot of resources you can get it. But this is the one. We can use MATLAB as well, but normally people use Python because Python is free, open source. You don't have to pay the software, the license of the software. Then you can have a system which is very cheap. So I think that's all from me. If you have any question, you can ask. If you don't have, then I think we can stop here. Back to the organizer. Thank you. See you again.
Okay. Thank you for Professor Kamalo. Now it's time for discussion. You have any questions? You can discuss with Professor.
Hello, Dr. Kamaro. Assalamualaikum.
Waalaikumsalam, Shahriza. Yeah.
Doctor, just one question out there.
Yeah.
Just now, with the geodetic techniques,
Geodetic, okay.
okay, what's the threshold if you monitor landslide using the geodetic techniques? Is it different, the threshold from one position to another position, or is it slightly the same?
Again, Shahriza, position of
Is it the threshold the same from maybe position A from
okay.
this slope in comparison with this slope, B slope? The
Okay.
threshold of the movement of the soil.
All right. Okay.
Yeah.
Okay. The basic idea of to have the real RTK, real time kinematic. I give you the example. We are going to install deploy 7 station, including the base station at the highway. But finally, due to the insufficient budget, we just managed to install 2 monitoring station, 1 base station. So back to the question, we hope that we can get the data uh, from the station 1 and station 2 within the radius of 50 meter. If there is any changes or deformation, soil deformation under the coverage of these 2 stations, it will refer to the position of the base station. So the changes up to the 2 millimeter and angle up to the 4 to 5 degrees. So if there is a change between in that area, in that coverage of the location A and location B, by referring to the base station, we can detect it. We can detect the changes, the soil changes. But still need a decision whether the changes is can cause the landslide or the changes is just a normal changes. So that is
So you mean the changes will be decided by the stakeholders. If this the threshold for this place, if it goes about maybe 2 meters, if the threshold is 2 meters,
yes, correct.
not,
Yeah.
okay, I see.
Because the location that we install the system is the area where there is a quarry. Quarry.
Yeah, Corey, yeah.
One month maybe they use a bomb to explode the hill to get the so this
Yeah,
will
to
be
take
a
the soil.
disturbance to our system. That's why we want the data, then we will come up with our solution. I mean, it is not just easily to apply all the ready system, but we need to do some research. We come up with the very good decision, and also
Okay,
based on the
I see.
stakeholder information feedback from the stakeholder. Yeah. Thank you.
I see. Okay, thank you.
All right.
Okay. Anyone else?
We have a professor, Dr. Sabira here. She's also working with me since 2016, but now she's no longer with University of Malaysia Pahang.
Yes. If you have questions, you can connect me after class. I can inform the Professor Kamalo.
Okay. Thank you very much.
No questions? Okay, never mind. Now I suggest everyone turn on your camera. We took group photos. What is the special moment? Okay, today so many people. Okay. Everyone, I remember we have the last class on Thursday. Okay, okay, and see you.
Done already. Okay.
Okay, class is over.
Thank you. See you again.
See you.
Bye-bye.
Thank you.
Bye.
Bye bye.
Okay, thank you, Prof. Okay, bye-bye.
Professor, could you send me your slide? I want to say your slide.
Okay, sure. I will send it to you. All right.
Okay.
Okay,
Thank you.
bye-bye.
Goodbye. Bye bye.